Before we start the new packet, I would like you to turn to page 142 in your last packet, just the optimization. I want to do number 13. You are going to have something similar to this on your assignment from the economic packet, so I want to make sure we go over something like this. So this one says on the same side of a straight river are two towns, and the townspeople want to build a pumping station S, which is right here, that supplies water to them. The station is to be at the water's edge with pipes extending straight to the two towns as shown in the figure below. Where should the pumping station be located to minimize the total length of the pipe? So we're trying to minimize this distance right here plus this distance right here. We want to minimize that because that's where the pipe is going to be laid. So if we call the distance, so town 1 is 1 mile from the river, town 2 is 4 miles from the river. So if we call this length right here x, and this distance you can see is 4, then we can come up with an expression for the pipe that goes from town 1 to the station. So first of all, I'm going to use L for length. So the length of this one here is going to be, using the Pythagorean theorem, is going to be the square root of x squared plus 1. And then, so we're going to have that in our total length, x, the square root of x squared plus 1. And then if this whole piece is 4 and this is x, then this has to be 4 minus x, and this is 4. So we get the square root for this piece here of 4 minus x quantity squared plus 4 squared. Okay, so again, using the Pythagorean theorem right here, so we have the square root of 4 minus x quantity squared plus 4 squared. Okay. Now we got to just remember we are trying to minimize this length, so that means we're going to have to find the derivative. So and set it equal to 0. So we got a little bit of cleaning up to do on here. So I'm going to start by kind of setting this up. So we have x squared plus 1 to the 1/2 power plus, and then if you, and maybe even off to the side, I know 4 minus x quantity squared is going to be 16 minus 8x plus x squared. If you FOILed this, you would get that, plus 16. So I get x squared minus 8x plus 32. So that's what that simplifies to. So I'm going to use that, x squared minus 8x plus 32 to the 1/2 power. So that's just setting it up. So now I can take the derivative. So L prime, we're going to have 1/2 x squared plus 1 to the negative 1/2. Don't forget the chain rule, times 2x plus, and this part is going to be 1/2 x squared minus 8x plus 32 to the negative 1/2 times the chain rule gives me a 2x minus 8. Once again, kind of a mess. So what can we do to simplify that? Well, this 2 cancels with this 2, but that's about all I can do there. And notice that I can factor a 2 out of the 2x minus 8 and then cancel it with this 2 down here. So I'm going to cancel that, and then this is going to be an x minus 4 instead. So what do I have? We've got, I'm going to flip this down. I have an x on the top. I'm going to flip this down to the bottom. So I'm going to have x over the square root of x squared plus 1. Then we'll have the x minus 4 on the top over the square root of x squared minus 8x plus 32. And I'm pretty sure at some point we're just going to use our calculator to set it equal to 0. Well, let's see what happens. I'll keep going. If you were going to find a common denominator on this, you're going to multiply this fraction here. I'm not going to write it all out. By, well, yes, I will. The square root of x squared minus 8x plus 32 on the top and bottom. And this one, the square root of x squared plus 1 over that itself. So now I have x times the square root of x squared minus 8x plus 32 plus x minus 4 times the square root of x squared plus 4 over my common denominator. So then I'm setting that equal to 0. So that means I'm going to take this numerator and set it equal to 0. I'm looking at my work, and on my work next, oh, wait, x squared. Hold on, something's not right. That and that. Sorry. You guys have probably been wondering. She's wrong. Okay. So I think I have everything in the right place now. And then I just have an answer. So I'm guessing I must have put this in my calculator, and I'm not going to go through and do that. But when you do, you get a nice answer to 0.8 miles. And then you really should verify that is a minimum. So if you plug in something smaller than that, I mean, yeah, it's kind of a mess. It is. You do get a negative. You do get a positive. I mean, you could use your calculator and do that. Pick something and plug it in, or graph it and show that it's below the x-axis and then above. So if they want to minimize the total length of the pipe, then they should. That's how they should divide that up, so that they use the least amount of pipe. Okay, so I know that you have something. Hopefully, the one you do is not that messy, but it does kind of get a little bit messy on there. So this one won't be so bad. This is an economic problem. The method is the same. So we're still going to do, we're basically finding a primary equation, coming up with the derivative, set it equals 0, and showing if it's a max or a min. So a trucking company has determined, and don't forget, if it's a closed interval, you have to check the endpoints, because sometimes the max or min is there. A trucking company has determined that the cost per hour to operate a single truck is given by this function, where S is the speed that the truck travels. At what speed is the cost per hour a minimum? Okay, well, that seems pretty straightforward, because this is the cost per hour. We want to find where that's a minimum. What is the hourly cost to operate the truck at that speed? Assuming that the truck can travel from 0 to 75 miles per hour, what is the range of hourly cost to operate the truck? So first thing I'm going to do is find C prime of S. When I do, I get 0.2 S minus 10. Then I'm going to set that equal to 0. Again, this one pretty straightforward, especially after the last one. So we get dividing by 2/10 here. So we get 50. And that would be speed that the truck travels. I'm assuming miles per hour. I don't see anything. Yeah, miles per hour. Okay, so that would be the speed. At what speed is the cost per hour a minimum? So we can show that that is a minimum. So we have 50. If we plug in something smaller than that, like say we plug in a 20, then you're going to get something negative. If we plug in something larger, like a 100, you're going to get something positive. Okay, what is the hourly cost to operate the truck at that speed? All right, so then, by the way, part A is just 50 miles per hour. If I call that part A, we'll call this part B. What is the hourly cost to operate the truck at that speed? Well, the hourly cost is just C of the speed, so C of 50. And when you plug a 50 into this, you can show that with your calculator and verify that, but you should get $200. And then the next part we'll call part C. Assuming that the truck can travel from 0 to 75 miles per hour, what is the range of hourly cost to operate the truck? So if you evaluate C of 0, plugging in a 0, you would get 450. And if we plug in a 75, we get, ooh, my calculator disappeared, 262.50. Okay, so then the question says, what is the range of hourly cost to operate the truck? We know that the minimum cost was, because we already calculated the minimum cost, so be careful. You can't just go with this 0, because that's not the minimum cost. The minimum cost we found was 200 because we solved for that. So then the range of hourly cost goes from $200, because that's what we found was the minimum, to $450. That actually was the highest cost associated with from 0 to 75 miles per hour. So your homework is from the economic packet, page 146, 147. It's numbers 3, 6, and 7. And I'm sorry, that was wrong. It's numbers 1, 2, and 8 on page 146 and 147. And number 8 is the one that you're going to do kind of with the Pythagorean theorem idea. So that's why I wanted to do that other problem that we did. I don't think it's as messy. Hopefully not. Anyway, so try and get those done. We can go over them in class, whatever questions you have.